Hey everybody. Um, we're moving into the next unit, Unit 2.2. Unit 2.1 was all about putting stuff together. If you haven't finished your assembly or if you need some help on something, let me know. We can always have a Zoom one of these days or two of these days this week. If you have specific questions and you think that no one else has this question, we can always Zoom after school if we need to. I just want to make sure we have all those things caught up too. Unit 2.2 is about taking things apart. So reverse engineering, the bell work that you may have done today has something to do with that, because I've asked, hey, have you ever taken something apart before? Have you undone a pencil just to see how it works or mess around with it just because you can, put it back together again? Have you taken apart anything at all? And if so, why? That was the bell work. And if you have, you've kind of done something kind of like reverse engineering. Reverse engineering is a process that involves a study of an object's visual, functional, and structural qualities. So visual, what's it look like? Is it aesthetically pleasing? Does it look good? How does it look when you're holding it? Things like that. Functional, like how do the parts work together? Is it something that is efficient? Does it use a lot of energy and not a lot of output? Does it have something where maybe people who have a disability couldn't use it? What's the function like? How does it work? What do you put into it? What comes out of it? And then structural qualities, how's it put together? What's holding it together? Why is it staying the shape and the size it is? That's structural qualities. And the questions we might ask is like, why? Why do we want to take something apart? There's various reasons. You've probably taken it apart just to see how it works or to see how you can fix something, but there are a lot of other reasons as well. In some cases, you may have to either create or recreate documentation about a product. Maybe that documentation was lost or destroyed, or it's never formalized, or maybe it just needs to be updated. It's, you have an update to your product, you haven't updated your documentation, you might need to do that. You also might want to gain a commercial or military advantage over a competition. You might want to find out how another company's product works, or how another government is building their drones or their weapons. What do you think Apple does every time Samsung comes out with a new phone? They probably get their hands on several and bring them back to the R&D lab and take them apart and say, hey, how do they get so many megapixels in that camera? Or how come the microphone quality is so good in that one? Whatever Samsung's good at, better than Apple at, I don't know. I don't know that much. You probably know more than I do because I haven't bought a new phone in a long time. What else? You might want to model a product for analysis and testing. You might have a product and you might want to say, like, how much strain does it take before it breaks? You probably don't want to sit there and break a bunch of your products. You don't want to make it and then go to the trouble of breaking it. But what you can do is you can say, okay, here's a part. It's made of steel. I'm going to model it in Onshape or something similar. I don't know what Onshape's analytical capabilities are, but I know like SolidWorks and Fusion 360 and other high-end, expensive professional programs for computer modeling. They will take your model and it will apply the properties of that material and say, if this is it's made out of steel, and if you push down on this end of it while this end is fixed, it will take this much force to bend the steel, and it'll take this much force to shear it off. This is how it would change. If you bend it a little bit and bring it back again, then the structural integrity over here is what's going to be compromised. This is the weak spot. So then you can say, oh, look, we can make this part a little thicker because it's going to need it to support more weight. So that's kind of what you might want to do. You don't want to break a bunch of stuff. You don't have to. You might see a product you made or your company made, and you might see a competitor has something very similar. In fact, you own a patent on something, and maybe they've actually copied something they shouldn't have, and it's your company's property, your intellectual property, your copyright. So you want to make sure before you file any lawsuits, because that's expensive, that they actually are infringing, that you would actually have a chance of winning your lawsuit. If it just looks like yours and you don't have the patent on the look, but the function is slightly different, then you don't have any say. So you have to make sure that what you think they're copying is what they are copying, and before you proceed with any legal proceedings. And you might determine why something's failed. I don't know if you ever had this happen where something in your house breaks and you're like, oh, maybe I can fix this. You take it apart, you see what's broken. We had an electric pencil sharpener, and it works great. It was the best one we've ever had. It's probably 20 years old now. It was a Boston, I forget now. But we took it apart. One of the gears had broken, and some research online, we discovered that one gear is like the only thing that ever breaks on these, at least up till now. And there's a guy on eBay who sells 3D printed gears out of a good material so that, for $5 you can fix this thing and it functions just as good as before. And that's great. Figure out why it doesn't work, fix it for $5 plus shipping. I mean, that's cheaper than buying a whole new one that might not work because they don't make them like they used to. And you also might want to figure out ways to improve on someone's design. If you're using a product and you're like, this kind of works, but it'd be better if it could do this, then you might want to take that thing apart, see how it works, and see, maybe I can change something here and make my own version of the product that works better. So those are some reasons why. I've grabbed this graphic off the internet. There's usually a process involved. There are several. I mean, it's like the engineering design process has kind of set, the scientific method has kind of set steps in stone. Engineering design, reverse engineering has a bit more flexibility, it seems, when I go look online for it. But basically, the first thing you're going to want to do is figure out the design's purpose. Oh, they misspelled purpose. Ha! Now that I'm close up, I can read it better. I'm standing across the room and it's on the big screen. I can't read it as well. You determine the design's purpose. I might need to change this slide before I put it online. So you determine the design's purpose. That means like, hey, what is this? What problem is it trying to solve? How does it solve it, etc.? Like, what's it doing? Why are we doing this? Next, you're going to observe how it works. Before you take it apart, you probably want to make sure you know how it's supposed to work. And then step 3, you disassemble or deformulate. So far, I've been talking mostly about taking stuff apart, like pulling, unscrewing things, pulling things apart, pull the pieces out and look at it. But you might also be deformulating. You might be taking somebody's, for example, a makeup product or a shampoo or hairspray and taking that and analyzing its chemical composition and saying, hey, what do they have in theirs that works? How could we maybe fix ours a little bit? Oh, they have this in theirs? I wonder how that would affect our recipe. It's kind of like people who make copycat recipes online. Like, hey, this place has the best rolls in town, but they have a secret recipe. Well, let's try it out ourselves. Let's make some. Let's see if we can figure it out. There are some people who can like taste something and they can tell what it's made of. That's really, I don't have that talent. I'm just like, it tastes good or it doesn't. Step 4, analyze. And that's just, you analyze what you find out. And then number 5, step 5, you do a report, you do a redesign, whatever your initial purpose was with taking it apart. Like if you're doing the patent thing, at that point you'd say, okay, here's my evidence. You have all this, the documentation's in the middle. You notice that's like an ongoing process. Every step you're documenting, you're saying, here's what's going on. I'm going to record everything. I'm going to make a document that has all this information. And then when you get to step 5, your documentation is there. All you have to do is really refine it or redesign if you're redesigning it, or submit it to your lawyers if you're suing someone for patent infringement. And that's basically it. The version of this online has like a little controller you can look at and you can sort of follow the steps on there. That's one thing. What I had them do in class is I had actually several steps that they could do. Let me grab my paper. I've got to stack them down here. So I put together this little worksheet or steps instruction paper. And it says, first thing you do is you're going to sketch the product, then you're going to write a sentence describing it. I'll link this if you're going to follow it. You describe it in a sentence or two, include some interesting feature of the product. Then you manipulate it. What are the functions of the product? How does it work? What do you think? What do you have to do? What's the user have to do? And what's the output supposed to be? How many parts do you think it has? That was kind of a guess before you do take it apart question. And then take it apart, keep the pieces together. Don't force them or break them because it might not go back together again. And then sketch your parts, label them with a number so that you can reference them later in your documentation. And then a little description about what the parts do or what you think they do. Then you put it back together. And so I've given everybody, if you have your engineering notebook, you have these papers in it. If you never got one, please send me an email. I'll put one together for you and put it in the front office. It's got several pages like this where you can, title it and do your work in this area. And then if you need to, if you have a team members or if you need to have a witness or something, there's places to fill in that stuff. But if you don't have an engineering notebook, you can either come get one, or I can put this page up as a PDF so you can print your own if you have a printer at the house. Everyone got, a paper to work on. If they have their engineering notebook, they've worked on it in their engineering notebook. If they don't, then they've got the paper, they've got the instructions. And the product I gave everybody was one of these nice little Papermate Clearpoint side clicker pencils. And I like these because I know how to take most of it apart, and I'm learning more. Like, I'm finding more things I can take apart now that I'm messing with it to take it apart and not just to play with it and write with it. If you have a pencil like this at the house, you can use that for your product. If you have something that you can take apart into more than a couple pieces, that's ideal. I got some dollar store pencils because I was like, how can I do this cheaply and get one for everybody? And the cheapo ones, they don't come apart nice. There's not a lot of stuff you can do with it. It's glued together. It's kind of crummy. If you would like one of these, let me know. I'm going to try to make sure if I run out of these, I'll have to go get more, but let me know and I can put one in the front office for you if you would like one. After they're done, they get to keep it, so you can have a pencil. I will leave a stack in the office if you guys need it. If you have something at the house you can use, please use that. So you do a sketch of it, and I've done my sketch. I'm kind of extra. My sketch is kind of extra. You don't have to do one quite as detailed. I can show you an example of what some of these papers look like from the students who've already finished. This one's in progress. Now, yours doesn't have to be anything, super duper detailed if you don't want it to be. It can be, if your drawings are super technical, like this student has one that looks really technically done over here. I don't know if you can see. I hope you can. I'll have to review this video. And then there's some people who just drew like the cylinder shape, kind of a rectangular shape with some parts coming off of it. I'm not judging your art. I'm not judging your technical ability. What I will look for is how you answer the questions, what parts you get apart. You can see this. So there's some examples. I think they're really cool. I'm really liking how they're turning out, and I might put them up on the walls around here later. So yeah, you take it apart eventually. You're going to describe it. Yeah, I'll put the instructions up. I'll put this video up. I'll put a version of this presentation, the PDF of these 4 slides or whatever I've gone through. I'll put a PDF of this kind of paper if you need some of those at the house. And again, if you need me to get you anything, please send me information. I will put something in the front office with your name on it, okay? And I'll let you know when that happens because it might be like 3 days from now when I finally get to go to the store and get more pencils. Alrighty, I'm going to find my recording thing and I'm going to see you all later. I'm going to make sure that y'all can see what I'm trying to show you. And then if I have to, I'll re-record, but hopefully not. Bye-bye, y'all. Have a good one.